You ever wonder how a computer goes from just following basic instructions to running a really smart, adaptable program? Well, today we're going to break down the core building blocks of code, from how programs make decisions and handle data to how they can repeat tasks like lightning. Let's jump right in.
All right, so here's our roadmap. We're going to start with what I call the two-gate problem to see how programs can make choices that depend on each other. Then we'll figure out how to handle a ton of data using lists, learn the tools to manage that data, and wrap it all up by uncovering the secret to writing code that's super efficient and reusable.
First up, the two-gate problem. This is all about how programs can handle decisions that build on one another. It's a really fundamental concept for creating any kind of smart logic in your code. So, think about it. What happens when a simple yes or no just isn't enough? What if, to get to the next step, you have to pass not just one test, but a second one after that? How does a program actually handle that sequence? Okay, let's use an analogy. Picture this. You're trying to get into an auditorium. First, you hit the outer gate, where they check your ID. If your ID is good, you get to move on to the second gate for a bag check. But if you fail that first ID check, you don't even get a chance to have your bag looked at, right? This second step is completely dependent on you passing the first. And here is exactly what that logic looks like in code. See how that second if statement for age is tucked inside the first one for the country? That's called a nested condition. The program will only even look at your age if and only if you pass that first test. And just like that, the two-gate problem is solved. Okay, so we've got the basic logic down, but what happens when you're not just dealing with one or two pieces of information? What if you're suddenly dealing with hundreds or even thousands of them?
I mean, can you imagine if you had to store a list of 750 students? Creating a brand new variable for every single one of them would be a total nightmare. It's tedious, it's messy, and it would make your program so slow. There has to be a better way.
And there is. The solution is the array. You can think of it like a super variable. It's one single container that can hold a whole list of values, keeping everything organized and in one place. Just look at that difference. All 750 names, all trucked away neatly inside one single variable called students. Now that is clean, manageable, and efficient code.
So, how do you grab just one specific item out of that big list? Well, every single element in an array gets a position number, and we call that number its index. And here is the absolute golden rule of arrays. The index always starts from 0. So the first item is at index 0, the second is at 1, and so on. You gotta remember that one.
All right, our data is all nicely organized. But data is almost never static, right? It changes. People get added, things get removed. So we need some tools to manage our list. Let's open up the Array Toolkit and check out 4 essential methods. First up, we've got push. This is super simple. It's just like adding a new item to the very bottom of your grocery list. Here, we're just pushing elephant right onto the end of our array. Done. And what's the opposite of push? That would be pop. As you can probably guess, it just removes the very last item from the array. So here, rabbit gets popped right off the end. Okay, so what if you want to remove something from the front of the list? For that, we use a method called shift. It takes off the very first element, in this case, cat, and then, just like the name suggests, it shifts everything else over to the left to fill in that empty spot. And to complete our basic toolkit, we have unshift. It does the exact opposite of shift. It lets you add a new element right to the very beginning of the array, pushing all the existing elements over to make room.
Now let's level up a bit. Those tools are fantastic for working with the ends of an array, but what if you need to perform surgery right in the middle of your list? This is where Splice comes in. And trust me, this thing is the Swiss Army knife of arrays. It lets you do 3 things in one go. First, you tell it where to start. Second, you tell it how many items to delete. And third, you can give it new items to insert right into that spot. It's incredibly powerful.
Now, this is a really important point. There's another method called slice with a C, and it sounds similar, but it's totally different. Unlike splice, which permanently changes your array, slice just takes a copy of a piece of it. It creates a brand new array and leaves your original data completely untouched. It's a much safer operation if you don't want to change your source data. So we figured out logic, we've organized our data, now we're at the final piece of the puzzle, efficiency. How do we stop ourselves from writing the same exact code over and over and over again?
Take a look at this. We're writing the same 2 lines of code to greet a user in different places. Now, just imagine doing that 100 times throughout your program. It's not just a waste of time, it's a recipe for disaster. If you ever need to change that welcome message, you'd have to hunt down every single instance.
The elegant solution to this problem is the function. A function is basically a reusable block of code that you give a name. Think of it like a recipe. You write the recipe down once, and then anytime you want to make that dish, you just call out the recipe's name. And this is where you can really see the magic. Look at that difference. Instead of repeating ourselves, we create one single greet function. Now, if we want to greet Hamza, we just call greet Hamza. If we want to greet Ali, it's just greet Ali. One block of code that we can use as many times as we want. So you might be wondering, how does the function know who to greet? Well, we use something called a parameter. It's basically a placeholder. You can see it there, name. When we call the function and give it the name Ali, that value gets passed into the function and temporarily fills that name placeholder. It's what makes our function dynamic and super flexible. And really, that's the key takeaway here. This kind of thinking, breaking down problems, organizing data, creating efficient, reusable solutions, it's not just for programmers. So I'll leave you with a final thought. Think about your daily life. What's a repetitive task you do all the time that could be simplified if you just turned it into a reusable function?